this. All right, number 16. There's number 16.
It's almost just like that other one.
Yeah.
And that's just showing your work, right? That's the answer.
Mm-hmm.
When's
All right.
the next quiz?
I don't know. What does the thing say? I'll have to check. Hope it's not today because there's not a working copier on campus.
No, it's after this.
Double angle. Okay, so then that means quiz is like tomorrow. Today, learn and apply the double angle trig identities. Day 77 quiz.
Then, another quiz.
Then, bam, another quiz in your face.
And then, cherry on the top.
And then a test. I don't know. I think there's one more chapter.
So, I have a question.
Yeah.
Are we gonna learn that stuff? The stuff after the quiz, the same day as the quiz, or are we gonna take a day?
We'll take a day.
So we'll have a
Because we
break.
don't have a block class, so.
Yeah.
No.
It's not really worth it now.
Yeah. The drop day has passed.
You've made it this far.
Yeah. Yeah, define made it, okay? Let's talk about that. We've made it this far. Exactly what is made it. All right. Some people are barely hanging on. I don't know. Yeah.
Since we don't have con, like, that's killing us. We should spread out. We should have one per 9 weeks.
One what?
Con due date per 9 weeks.
Well,
That way we get those bonus points if we need them.
yeah, except that the whole point of it is to finish before the test, the state test for 9th and 10th
Right.
graders, so we can see what you actually need to remediate in before the state test.
I mean, you can have like the last one due towards the beginning of every con.
What do you think this is? This morning class?
Gosh, I'll have to think about that.
Basically, all homework grades are like a test grade. They're worth the same.
No. All right, let's talk about the double angle identity for sine. Okay, if you're doubling the angle, that would be sine 2 theta, because you doubled it. So 2 times theta would be double angle, right? Or sine of theta plus theta. Now, we're gonna use the sum identities that we've already learned. So what's the sum identity for sine theta plus theta? What would that be? Sine theta times cosine theta plus
Cosine theta times sine theta.
well,
Theta
it's
1 or theta
it's
1,
like
theta
A
2.
B
Yeah,
A B,
yeah.
but here it's all the same thing, so it doesn't really matter. But I just want to put it in the right order.
It's like theta 1, theta 2.
Mm-hmm. I'm gonna reverse it just right here though. How many sine theta cosine thetas do I have? So sine 2 theta equals 2 sine theta cosine theta.
Makes sense.
Mm-hmm. Okay. I will say this, by the way. My calculus kids are coming in, some of them, and we're reviewing. And like we did a limit today, and if you remembered your trig identities from 11th grade, the limit was super easy because it equaled 0. But if you didn't remember your limits, from 11th grade, it was like impossible, and it took up like a half a sheet of paper. And when I showed them, do you remember this trig identity? They were like, oh my gosh. Like, let me find a clip and jump. Because it made that huge of a difference. So, we may not look at these every single day in calculus, but they do come in kind of handy. All right, sine 2 theta, or sorry, cosine, would be cosine theta plus theta. You remember this one?
Cosine theta times sine theta.
Mm-mm.
Or cosine theta times cosine theta.
Mhm.
Minus sine theta, sine theta. I wrote it down right, I just didn't say it right.
So cosine 2 theta equals cosine squared theta minus sine squared theta. Like, if it's that easy, why is there so much more square? Because there's actually more than one. Now, this, if you remember your Pythagorean identities, this equals 1 minus sine squared theta. So cosine 2 theta could also equal 1 minus 2 sine squared theta.
So are these like proofs almost?
Mm-hmm.
And then it could also equal, if you change the sign to the cosine, right?
If you'll remember, sine squared theta could equal 1 minus cosine squared theta. Cosine 2 theta could equal 2 cosine squared theta minus 1. That's the last one on that. All right, let's talk about tangent.
This one I don't know.
It's tangent. On here, it's just going to be tangent plus tangent.
It's like 1 minus.
1 minus tangent times tangent, because it's the same thing. You don't have to worry about your A's and B's. Simplify it. You have 2 tangent theta over 1 minus tangent squared theta.
And if you need to, like, you can change that to what, sine, cosine.
If you need to, but we don't have to right now.
Yes.
Suppose sine of theta equals negative 3/5 and tangent is greater than 0. Answer the following questions about theta. Okay. In which quadrant does theta terminate? Explain your reasoning.
3.
Why?
Because
Sine's
sine's the
negative.
y, and that's negative, so it's got to be 3 or 4. And since tan is cosine over sine, that means cosine has to be negative for it to be positive, so
Alright.
x more negative.
So, I can't write that fast. Since sine of theta is y over r, which usually r is 1, but since that's less than 0, then that means y is less than 0,
Mm-hmm.
right?
Is it y over r, or is it r over y?
Sine is y over r, because r is your hypotenuse.
It's 1.
And r is 1 in the unit circle,
Yeah.
Should be
which is always positive because it's a distance out. But then tangent tangent is y over x, and it's greater than 0, then x has to be less than 0 since y is less than 0. Therefore, theta terminates in quadrant 3. Whew. Okay. Draw the angle theta and label the reference triangle. Alright, so it's going to be in quadrant 3. It goes around like so. What was sine again? -3 and 5. And so what does this have to be? This adjacent
4.
side.
Negative 4.
-4.
How do you determine which way it's drawn?
What do you mean?
Like I have mine this way rather than that way.
You always draw it to the x-axis.
To the x-axis.
Uh-huh. Order sine 2 theta, cosine 2 theta, and tangent 2 theta from least to greatest. Alright, well first of all I've got to find them before I can order them from least to greatest. So sine 2 theta equals 2 times sine theta cosine theta. 2 times, what was sine? -3/5. Cosine is -4/5. So that's 24 over 25. Two times the cosine squared minus 1.
Where does the 2 come in?
It's the formula we just did on the last
Yeah,
page.
But on that one,
This one?
yeah.
3 times 4 is 12.
Okay.
Times 2 is 24.
Okay.
Alright, so that's 16/25.
But you just do it to the top one, not the bottom one?
Because it's top times top, bottom times bottom.
Okay.
The bottom of this is
Yeah.
1.
Yeah, okay.
Where was I? Oh, that's 16 over 25 times 2 is 32 over 25. Minus 1 is 7 over 25. Tangent 2 theta. That's 2 tangent theta 1 minus tangent squared theta. Alright, so tangent, opposite over adjacent. It's going to be 3/4 over 1 minus 3/4 squared. So that's 3 over 2. Oh my goodness. Okay. That's 9/16. 16 over 16 minus 9 over 16 would be 7 over 16. Flip and multiply. So that's 24 over 7. Alright. Which one of those is smallest?
7/25.
Okay.
Sine 2 theta.
What's middlest?
Sine 2 theta.
And who is the greatest? It's a tough one.
I'm gonna go with, yeah,
Yep.
2 theta.
we all know it should say I am right there because I am the greatest.
You don't need to brag. You
Just-
don't need to brag. Don't
Just
need to
stating a
boast.
fact.
But I'm like hot butter on your breakfast toast.
Alright, now I get to verify a true identity. That's going to be fun.
It's from, what is that from?
I have no idea.
I think it's, instead of hip hop, hibbity don't stop that.
Oh. I had a necklace on when I came to school. Not really sure what happened. I did. I had one on. Alright. Verify that the equation cotangent theta minus tangent theta equals 2 cotangent 2 theta is a trig identity. Alright. Well, let's see. Let's start over here because it's got subtraction and that's just one term. What's cotangent?
Cosine over sine.
And then that's going to be sine over cosine. So everybody with me so far? Okay, what is that? That's one of the identities we just did. What does that equal?
Does it matter what we use?
Cosine. 2 cosine.
Cosine 2 theta.
Cosine 2 theta minus 1 minus cosine 2 theta. Oh, never mind. Okay, I see what you mean.
Alright. I don't want to, but I'm going to work on this side because I can make this side look like that side in about 2 seconds. And I'm going to use more steps doing that. Cotangent is cosine over sine, but that's cotangent 2 theta. So it's cosine 2 theta, sine 2 theta. And plus, this will now, this on bottom turns into, do you remember? 2 sine theta
Cosine squared theta.
Cosine.
Squared
Cosine theta.
theta.
Oh.
Those two cancel out, and you have it. You're done.
Okie dokie.
Mm-hmm.
Makes sense.
Alright, let's work on this one. Sine 2x equals 2 sine x cosine x. Cosine 2x chooses to 1 minus Is it sine squared, 2 sine squared x? Nothing's going to happen to the top, but look what happens when I clean up the bottom. The 1's go away, and minus a negative 2 becomes a positive 2 sine squared x. Well, guess what happens to the 2's? They cancel. And this sine cancels with one of those, and you're left with cosine x over sine x, which equals what? Cotangent x. Aren't these great when they work out like that? What? These are beautiful.
And they work out.
I love them.
I enjoy knowing how to do them.
Mm-hmm.
Like, right now we're good. But like,
Oh, no, I wouldn't use that.
and then I see the next one, it's like, I want to vomit.
This one.
Basically what we were doing for a while there, just with new
Formulas, or,
tools.
Mm-hmm.
More complicated.
More stuff to memorize.
so would it be like easier now that we have these? Like if we went back into the other ones? Would it be
No,
easier?
not necessarily,
remember
because
running into this,
they were picked specifically,
Right,
so you didn't
right.
have to use that.
Right.
Mm-hmm. All right, I know this side looks more complicated. We're going to work on this side. Generally, we pick the complicated side, but I'm going to show you how you can make this side look like that side. And then we can tackle this side if you want to, if we have time, but I don't know that we'll have time. So this sine 4x, I'm going to turn it into sine of 2x plus 2x. Because what's 2x plus 2x? 4x, right? So that's sine 2x cosine 2x plus cosine 2x sine 2x, or 2 split these two up, so you have 2 times, right here I'm going to say 2 sine x cosine x
Why doesn't the cosine get it?
That's not its formula. Yeah, look back on how we came up with the formula. I scooted those, but I did not need that much space, by the way. Cosine 2x is cosine squared x minus sine squared x, or 4 sine.
So we just turned sine 2x and cosine 2x into the
Mhm.
formulas from the page before.
Yep.
Okay. Gotcha.
And then do some distributing and look what you have. If you keep that 4 out, you have sine x cosine cubed x minus sine cubed x cosine x, which is exactly what you started with. If you wanted to try to factor this side, let's just factor that side, see what happens. Oh, that already has stuff on it.
And you just factor sine and cosine out.
Mm-hmm. And you would be left with cosine squared x Oh, there's a 4 out there, sorry. Minus sine squared x. Which both of these match double angle identities. Both of these.
Yeah.
Okay. Okay, Blaine, you said why didn't the cosine get a 2?
Yes.
Sine 2 theta equals 2 sine theta cosine theta. Like, that's the actual formula. It doesn't get a 2. That matches that, or that, or that. So it doesn't, you don't need the 2. Does that make sense? At all? It's just, that's not,
It's because you're adding a sine cosine, not a
right.
not a sine plus a cosine. It's a sine cosine plus
Mhm.
sine cosine.
So the sine, because it's in a triangle, one that gets the 2.
Right. It's just like 2 times all of this.
Sine cosine.
You could put the 2 anywhere. It's
That's the whole thing.
yeah, it's like if you had
Sine
4 times A times B, it's 4AB. It's not 4 times A and 4 times B. You could put A times 4 times B and you get the same answer. It's all multiplication straight across.
I was just confused.
Mhm. Yeah. So if you look, if I just change this one to 2 times 2 sine x cosine x, no, cosine x, this one equals cosine 2x, this one equals sine 2x. That's what I have. I could change this one now to 1 minus sine squared, or 2 sine squared x, factor it again. And eventually I would get down to just 1 sine power. But I don't want to eat up that much time because I want you to have time to do. But I might play with that one while you're doing homework. Alright, day 76 homework. You have 2, find out where they terminate, and then order the values. It's just like what we were doing. And then you have verifying identities. You have quite a few of those. In your quiz, if you look, it says this is an identity quiz. You will not have to apply them. So you just have questions about the identities. You're not having to apply the identities.
Like what we were just doing.
Yeah. Mm-hmm.
So, are we having a quiz tomorrow?
You have a quiz tomorrow.